Yes, Manoj, I am expecting for an answer. Manoj Kumar S. Nikhil, would you like to answer the question? What are canonical forms or standard forms? Nikhil Jha, or anybody else wants to answer? What are canonical forms and what are standard forms?
Sir, canonical forms are like expressed in terms of sum of min terms and product of max terms, no, sir?
Okay, yes. So we are bringing them in the form of m naught plus m1 plus m2. Okay, just an example. So which means we are trying to extract data from the truth table, and we are going to see the equations. If possible, we will reduce the equations. When I say reduce, we minimize the equations. And once we are satisfied with the equation, then we will go ahead with forming uh, min terms and max terms. Okay. So I hope you all are clear till this point of time. Okay. So we will go ahead and continue with our discussion. Rakshita, I want you to mute. Can someone just inform Rakshita Sharma to mute? Maybe she has not joined the audio. Audio is not joined. Just someone inform Rakshita. I'm just pulling up the notes that we will be using for our class today. And yesterday we saw an example, right, as to how min terms were created. So today we will be actually looking into max terms as to how they are brought into standard forms. Okay, and we will try and understand as to how these simplifications are also done using various Boolean laws and you know, other minimizing techniques. So I hope my screen is visible.
No, sir.
Not yet. Okay. I think now it should be.
Yes, sir. Yes, sir.
Fine. Fine. Thank you. So this is what we saw yesterday, and then we try to code them in the form of x bar or probably only x if they have a high term or 1, and if it has a 0 then we put it with bar. Okay, uh, and then we used negation, which means we complemented them and converted them into max terms, right? And then we saw an example of an equation was given, and then to this equation we wanted to bring them in standard forms. In order to bring them in standard form, see, it's just like, can I add 1 kilo and 1 liter? Not possible, right? I have to get them to a standard form wherein I can add 1 kilo plus half kilo, right? It's because my SI units are the same. Similarly here, if I have to bring this a plus b bar c into its standard form, I will have to use the other remaining alphabets left out by using b plus b bar, c plus c bar. Okay, so in this way I get a, b and c, and similarly here, since a is missing out, I use a. So in this way I can actually rearrange and get my standard form or canonical form. Now this was our discussion till yesterday as to how we get these min terms, and now we will go about checking out as to how we can process max terms. Okay, fine. Each of the 2 raised to n functions of a binary variable can also be represented as POS, which is product of sums. To express a Boolean function as a product of max terms, it must be brought into a form of odd terms because it is product of sum. So you have some terms and those are into multiplication form. Okay, so this is nothing but your max terms. Fine. So to understand this better, let us see an example. Okay, we have to express this Boolean function xy plus x bar z in POS format or max term format. So let us take it. Let's take the function f is equal to xy plus x bar z. Okay, and what we will do here is we will use this Boolean law. Okay, we will use this Boolean law where a plus b, a plus c will be nothing but a plus bc. You can actually go ahead multiplying this. Okay, and at the end you will actually get a plus bc. So the same rule we will be applying it here. Okay, so the same rule, a plus bc, which is nothing but a plus b into a plus c. So we will be using x plus xy plus x bar. Okay, and then xy plus z. Okay, so the same rule is applied here. Okay, so here we will see that xy, okay, is taken like a. Okay, and your bc, b is here x bar and c is z. Okay, compare these two equations. Compare these two equations. Okay, where a is nothing but your xy plus b is x bar and c is z, and we apply this rule here. So a, which is nothing but your xy plus b is x bar into a is xy plus c is your z. Okay, so I hope you're clear with what we are trying to do. Okay, so now it's all about rearranging them. Okay, so so x bar plus xy. Okay, what I will try to do is I will try to rearrange them. Okay, I will multiply them. Okay, and then I will try to rearrange them. So once I do this, I know that x plus x bar is equal to 1, so I can neglect it. I'll have to keep x bar plus y and x plus z and y plus z bar. So you can actually try and multiply these terms individually. Okay, and you will actually get these 4 terms. Okay, and since we all know x plus x bar is 1, we will eliminate that. Okay, because it's not going to harm the value of this equation. So we are going to retain whatever was left out, which is the free terms. Okay. Now the function here has 3 variables, which is x, y, and z. Okay. So what we will do now, we will have to get them in standard form, right? So if we have to get them in standard form, just like how we did for the previous example, here also we will be using the same concept. Okay, so here I have x, y, I do not have z. So what I will do here, I will just use the z into z bar. Now remember, okay, this is our max terms. And similarly, I have x, z, I don't have y. Okay, so why am I doing this? Let us say y is equal to 1. Okay, so 1 into 0 is how much? 0. So anything with 0 doesn't change the value. Okay? So it is as good as having it or not having it. Okay, so it's not impacting the value of this equation. So xy is here, I take z, xz is here, I take y because y is remaining, and yz is there, there's no x, so I take x. So x and x bar. Okay, now, as usual, what we do is we try to multiply, we try to common out the terms. Okay, see here I have x, y plus z, x, y, z. Multiple terms I don't keep, right? And similarly here you have x bar, y, z. Here also you have x bar, y, z. So common terms, I just keep one of them. I just keep one of them, and the remaining ones are brought down. Okay. Now the same concept is used. Okay, wherever you have r. Okay, now keep in mind the order of the equation should only be x, y, and z. I cannot keep y plus x bar plus z bar. Okay, do not arrange it in that way. Okay, this is a very important point. Please note down any equation that you are finally bringing out, make sure that all are xyz, 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 and xyz without having this order. Okay, your values here are going to change. Now why is it important? It's important because here I'm taking this bar, right? So bar is considered in max terms, so which means I'm going to take it as 4. See, 4 to 1, right? So the value 4, so x bar, so 4. Here x and y, so 4 plus 1, which is 5. Okay, similarly here there is no bar, so I take it as 0. And in the last one, okay, I have y bar and z, so I get m2, right? Now once I get this equation, what we do is we rearrange them. Okay, because 1 into 2 can also be written as 2 into 1, I get the same answer. So 0, 2, 4, 5. Okay, an ascending order. So I can write it as f is a function x, y, z. Okay, pi. Now keep in mind here we are using pi. Okay, now someone wants me to explain the last step, right? Now, I think till here we are very much clear, right? We have the common terms. Okay, so I will not say, for example, let's take it in this way. Mm, I have I have two pens, but I will be using only one pen for writing. Okay, so I will not be using both the pens at the same time. So similarly here, what we will do is we will not be using both of these terms, which means if I have two of these terms, they are not going to impact if I just have one, because the purpose is solved when I have just one equation here, just one term here. Okay, so I will have this term because it is 2, I will just take 1, and everything is taken as usual. Now, how is that I'm getting 4? Now what you can do is you can also write this as 1 0 0. Okay, so what is this 1 0 0 4? Right, this one can be written as 1 0 1. So when you write 1 0 1, what happens? It is 5. So I am turning high whenever there is a bar. Whenever there is a bar, okay, that is considered as high in max terms, not in min terms. Keep in mind. Be very careful while solving these kind of problems. We have to see what is the question. Okay, now they are telling max term, so as soon as they say max term, your set of rules should completely change. Okay, whatever set of rules that you are having for midterm, it becomes exclusively different for max terms, right? So here, um, 0 0 0, so it is as good as m naught. Okay, so here it is 0 1 and 0. Okay, yeah, this is only z here, x y bar z, yeah, x y bar z, there's no bar for the z. Okay. So this will be 1, sorry, 0 1 0, so it is 2. Okay, so in this way, sign, is it clear as to how we got m4 m5 m0 and m2? Okay, fine. So this is how we get this form, and this is rearranged here. Then I use pi to represent my max terms, and just these numbers are put inside 0 2 4 5. So this is going to be my final standard form. Now in max terms I use pi, min terms I use summation. Okay, so this is how we are actually going about with standardizing our min terms and max terms. So students, any doubts you can please ask me, because this is a very important concept, and we will be having such kind of problems in your exams as well as in your internals in your CIE. Okay, so any doubts you can feel free to ask. Okay, because similar kind of problems will be discussed. Any doubts, students? Yes, Bhargav says it's clear. Anybody else? Any doubts? Please feel free to ask. Okay, because uh, as I move forward, okay, you shouldn't have any doubts. Okay, there's no point in moving forward if you have any doubt. Okay, so anywhere at any point of time, you can always raise your hand, or you can post a message in the chat box, or you can unmute and you can ask me the question. Okay, fine. And for the benefit of all of you, okay, what I'm doing is, you all are very much aware. Okay, I'm posting the videos so that you can always look into it, try to understand. Anywhere you have doubt, you can rewind it, right? You can go back to that uh, point of explanation and you can revisit it. Okay, so in that way, you become more confident in concepts that have been done. Okay, fine. So moving on to our discussion, today we will try and understand how these conversions are done between canonical forms. Okay, so from one form to another form. So we have seen an example exclusively with minterm. We have seen an example exclusively with maxterm. Now we will try to convert, or we will try to play around changing minterms to maxterms and maxterms to minterms. Okay. So the complement of a function is expressed as the sum of minterms equals the sum of minterms missing from the original form. Right? So we will try and understand how to understand, or how to go about getting this detail. This is because the original function is expressed by those minterms that make the function. Now here in minterms we are considering only if it is high, right? So if it is high, then we are taking up that equation. Now if it's a 0, then we are neglecting it, right? As we saw in the previous truth table, You can see here, right? You can recall. So in this truth table, okay, an example that we saw here, your function, okay, your function f1 and f2, okay, wherever we have 1 as the output, okay, those are considered. The ones with zeros are just left out. That is what I'm trying to say. Wherever there is a high in f1, okay, in the output, only those are considered. This is about your min term. But in max term, it becomes the opposite. Okay, so understanding this concept is very important. Are you considering 1 or are you considering 0? Okay, so take this truth table as an example. I have 2-bit combination, so which means I get about 4 combinations, 0, 0, 0, 1, 1, 0, 1, 1. Okay, so for the last one, okay, I get high value. So which means what is going to be my equation? F, and what are my input variables? A, B, and that is nothing but your summation 3. Now when I say 3, it means that I am getting the function, or the output of the function is high for the input variables A and B at which value? 3, at this combination. So this combination is nothing but your 1, 1. So this is how you have to understand. Okay. Now this has a complement that can be expressed as, suppose I take a complement of this. So what is a complement? Just the opposite. So instead of considering 1, if I consider zeros, that becomes my complement, right? So f bar, okay, a comma b is equal to, so if I leave out 3, what are the terms remaining? Just 0, 1, 2. So it is m0, m1, m2. Now if we take the complement for the second equation, okay, so what do we obtain if we just put the complement here? M0, m1, m2. So using our De Morgan's theorem, it becomes what? M0 bar into m1 bar. All the additions become multiplication and the bar breaks up, right? So once the bar breaks up, we will have this, bigger bar broken up into smaller bars for each terms. Okay, so this is how you can understand. And min term bar is nothing but your max term, right? Min term is max term. Okay, yes, Bhargav, I will repeat the concept again. So I think you have understood till this concept, right? How this function AB, okay, is equal to summation 3, what it is trying to say. Till here, is it clear? Till
Yes, sir.
equation 1, till equation 1 it's clear.
No, sir, actually. How?
Till equation 1, no?
No, sir, no, sir.
Okay, fine, no problem. Look at this truth table now, okay, and this is just a random truth table, okay, that you can consider. So I have given the function high, or 1, the output 1, for combination 1, 1, okay. Or we can even consider this as our AND gate, right? 0, 0, 0, 1, 1, 0, 1, 1. So this is the truth table of AND gate. So here in this AND gate, I am getting the output high only for 1, 1. So 1, 1 means what? 2 plus 1, right? 2 plus 1 means what? 3. 0, 1, 2, 3, right? So my function a comma b is equal to summation 3. So if I have to write an equation for this, this is how I'm going to get my first equation. Till here, is it clear, Bhargav?
Yes, sir. Yes, sir.
Okay. So moving forward, now keeping in mind that min terms, the opposite of min terms is max terms. If I'm considering 1 in minterm, I'll be considering 0 in max terms. If I'm writing minterms in small m, I'm writing max terms in capital M. So everything is opposite. The consideration of 1, taking up zeros, the way we write, the way we represent, the logic, everything is different, exponentially different between minterms and max terms. Right. So now if I take a complement, which means the opposite of this minterm, how do I say that it's a minterm? Because I have a summation, right? See the previous equation. If it has a pi, then it's a max term. If it has a summation, then it's a minterm, right? So using this summation, I understand that, oh, this is a minterm. If it has a pi, I understand, oh yes, this is a max term, right? So I
Yes,
have
sir. Yes, sir.
minterm here, I complement it. So when I complement it, what's going to happen? Apart from 3, okay, I consider the other terms, which is 0, 1, and 2. Okay. Now, how do we represent this minterms? Minterms are normally represented with m0 plus m1 plus m2. Let's go back to the previous table where I had shown you how we represent them, right? So this is how we represent them. Okay. So 0, 0, 0, okay, m0, m1, m2, m3. Okay. So all this you should keep in mind. Fine. Okay. So if I leave out 3, what are the terms remaining now? 0, 1, 2. Now remember there is a bar here, f bar. F bar means I understand that I have actually considered min term here, but I'm doing a complement. So using min terms, I am deriving max terms. Okay. Now if an f is here and pi is here, then it should be a max term. But there is an f here, there is a summation here, which means it's a minterm. If I put a bar for the function, it means that using my minterms, I am trying to derive max terms. Could you all please note down this point? Please note down the explanation of this equation. Okay, whatever I told you, put it in your own words in your notebook. Now remember, I want all of you to maintain notebook. I hope all of you are writing down your notes, right? Because this is very essential. Even if you don't understand a single bit here, okay, even if 0, 1 becomes 0 and 0 becomes 1, your whole answer becomes wrong. Okay, so this subject is in such a way that you have to understand every 0 and every 1. Okay, so take it seriously. Okay, do not take the subject light, because it's a very important subject. Once you understand the concept, okay, you will get marks, you will get high marks actually in this subject. If you do not understand, it is a 0. It is just like binary, either it's 1 or 0. 1 you get high marks, 0 you don't get marks at all, right? So please, wherever you feel doubt, wherever you're not able to follow, make sure that, okay, you ask me questions so that I am there to get those concepts rectified, okay, and clarified for you. Now write down this explanation which I told you for this function f. It has a summation, which means it's midterm, and if it has a bar, it means that I am using midterms for bringing up max terms. This should be on your notebooks, so that whenever you go through my video and whenever you see your notes, you should be able to combine it and store the knowledge in your brain. Okay, fine. Moving forward. So we will be taking a complement. Okay, I have taken a complement. So uh, f bar is nothing but my 0, 1, 2. Okay, now I have to put that bar here, right? I have to put that bar, so which means I have to take another complement. So if I take another complement, what is happening? I can put that bar here on M0, M1, M2. So once the bar is there, using my De Morgan's theorem, I can split it up. M0 bar plus becomes multiplication into M1 bar into M2 bar, right? I am able to split them. So min terms complement is nothing but max term. Okay, so capital small m turns out to be a capital M. So I get 0, 2 and 1. Okay, it's not 3, it is 1. Okay. So what I will do here, I can even rearrange them as 0, 1 and 2, or I can just write it as 0, 2, 1. I would suggest that you guys always try to put it in ascending form. Okay, and here we go, your summation has turned into 5. Okay, so it becomes 0, 1, 2. So in simple, try to understand, in simple, okay, 3 is for min term, okay, and 0, 1, 2, 0, 1, 2. So zeros are here. So if we consider zeros, it is for max terms. And I can say that summation 3, which is min term, when I consider only 3, okay, and when I use max term, it's a pi, and I should consider 0, 1 and 2. Any doubts, students? Any doubts?
No, sir. No, sir.
Okay, fine. So I hope you have understood as to how we play around with min terms and max terms, how we convert them from one form to another form. Okay, so to summarize, you can uh, you can probably put it in your notes. If one is considered, then we take up uh, as min term. If min term, then we consider one, that is high output. If we consider a max term, then we look for zeros in the output function f. Simple, right? Can I move forward? Can we go to the next
Hello, sir.
concept? Can we go to the next concept? Someone has a doubt?
Could you repeat that statement again?
Um, one is considered for a midterm, and 0 is considered in the bracket, you write in the output, close the bracket. 0 is considered for max terms. Can I proceed?
Yes, sir.
Okay, so this is how we convert them from one form to another form. Now, how do we generate switching equations from truth table? Now we had seen that we had generated some equations for one problem, right? If you can recall the flow chart that we had, right? Can someone tell me what was the first thing in the flow chart? Remember, we had a flow chart, and then we discussed about a problem where we had a motor and two operators, and then we had a flow chart. Can someone tell me what was the first point, or how does our flow chart start? Chirag, can you tell me how it goes on? Flow chart. Chirag Sharma. Stanley, would you like to answer that? Stanley Davis, yeah, go on. Yes, go on, Stanley. I can't hear you. Go on.
I don't know properly, sir.
Okay, in the initial point, we had discussed the flowchart. Okay, so that flowchart I am talking about. Now, students, please keep in mind, okay, this is not only for Stanley or this is not only for someone else, XYZ. This is for all of you. Okay, the reason why I'm sending you videos is so that you guys will be in sync with me. When I say in sync with me, whatever concepts that I am teaching, you should be able to follow. If you are not following, then there's no point in me moving forward. Do you agree with me? Students, do you agree with
Yes,
me? Yes. So, if we are not able to understand what was uh, previously taught, okay, and if we listen to the next lecture, it's going to be difficult. Trust me. Okay. So that's the reason I am posting information to you. Please make use of this resource. Okay. Now during this pandemic time, we have to manage ourselves. Okay. If we do not manage time properly, it's going to be difficult for you, because as we keep moving forward, okay, what happens is the concept starts building. Okay. Now, Bhargav, I will send the notes. But as I mentioned previously, it will be sent only at the end of the module. Okay. So before that, okay, I am posting videos then and there every day. So using my videos, you can always get the notes and please note it down on your notebook. It's always advisable that you write notes so that you understand very clearly when you write something. If you just sit and watch, it is not going to help you. This is for everyone. Okay, please take my advice. We are still in the initial stage. Okay, do not go off track. Be in track. Okay, try to understand the try to understand whatever concepts are being taught then and there. Okay, the same day itself, your target should be before you go to bed, before you sleep. Your target should be whatever is taught for that day should be revised. If any doubts, the next class it can be taken up. Or you have Google Classroom, you have WhatsApp, you have WebEx, right? You have many platforms where you can reach me out. Yes or no?
yes, sir.
Yes, right? So just make sure that you guys make use the best use of all these resources available. Okay, I am not scolding you guys. Okay, I'm just advising you so that it is going to be helpful for you at the time of your examination. Because right now, if you take things seriously, okay, it's going to take you for a long run. Okay, so at the time of your examination, you do not have to panic because the concepts are already clear. You can just revisit them. Okay, so let us get back to the flow chart that I was talking about. You know, so the first one that we are going to have is the problem statement. So using our problem statement, we generate truth table. Can you please all of you note this down in your notebook? If you have noted it down, please turn your page and refer to it. If you have not noted this flowchart, please right now note it down. How many of you have noted down this flowchart, can you please raise your hand? You have an option where you can raise hand in your WebEx. Can you please raise your hand if you have drawn this flowchart? Good. I can see many hands coming up. Good. Majority of you haven't taken down it, right? You have not made note of this flowchart. Remember, I'll be keeping a quiz, okay, based on all this that we have discussed. Quiz 1 very shortly, okay, probably in another 2 days. I'll be keeping quiz 1. So quiz 1 will carry 5 marks of your CI, straight 5 marks, okay, and it's going to be based on whatever lectures we have discussed so far. So questions will be based on those lectures. So make sure that all of you go through the video properly. If you haven't attended my class, if you haven't, if you were not able to understand some concepts, okay. So scoring 5 marks becomes very important for you guys because that's a component of your CI. Remember, your assignments carry 7.5 marks. 2 assignments, which is about 7.5, which is 15. Quiz 1, quiz 2 will carry 5 marks, which is 10. So 15 plus 10, 25 marks. 25 marks from quiz and assignment, and another 25 marks from CI 1, 2, and 3. Okay, so I hope you are clear with this breakup. Are you all? Are you all clear with this breakup of marks? Jeffrey? Jeffrey, are you clear with this breakup of marks in your digital electronic circuits? Kamal? Okay, so understanding the importance of breakup of marks is important because you will be ready mentally as to how you're going to score things. Okay, so I will probably leave you guys here. Okay, uh, and then we will join back in some time, probably after 10 minutes. And till then, I'll be posting in the attendance in Google Classroom, and we will take up this, okay, switching the equations and how these are generated using truth table. Okay, so what I wanted to say here is the problem statement, truth table, switching equations, simplifying those equations, logical diagram, and finally the circuit. Okay, problem statement, truth table, equations, simplified equations, logic diagram, and finally is your logical circuit. Okay, this flow should be in your mind. Okay, so we will continue in the next class. Next hour is also mine. Okay, so I'll be sharing in the attendance, and we will join back. Okay, at probably 11:10. Okay, thank you.